National Electrical Code Articles 701.17 and 701.18 address specific requirements related to emergency power systems and their automatic transfer switches. Article 701.17 focuses on the accessibility of the emergency system. It states that the emergency system equipment must be readily accessible for inspection, testing, and maintenance. This means that the equipment, including the automatic transfer switch, should not be obstructed or difficult to reach. There should be sufficient clear space around the equipment to allow qualified personnel to safely perform their duties. The code does not provide specific distances, but it emphasizes the importance of easy access. Consider factors like the size of the equipment, the working space needed by electricians and technicians, and any potential obstructions that might hinder access. Article 701.18 covers the sources of power for emergency systems. It states that the source of power for an emergency system, such as a generator or battery bank, must be located in a separate room or enclosure from the normal power source. This separation is intended to prevent a single event from disabling both the normal and emergency power systems. The code requires that the emergency power source be protected from hazards such as fire, flood, or other events that could compromise its operation. The specific distances or separation requirements may vary depending on the type of emergency power source and the building construction. Consult with local building codes and fire safety regulations for additional guidance on separation distances. Consider the potential hazards in the area, such as flammable materials or sources of ignition. The separation should be sufficient to prevent a fire or explosion from affecting the emergency power source. In addition to the NEC requirements, it is essential to follow the manufacturer's recommendations for the installation and maintenance of emergency power systems and automatic transfer switches. The manufacturer's instructions may provide specific guidance on the location and spacing of equipment. Properly installed and maintained emergency power systems are crucial for ensuring the safety and reliability of buildings and facilities during power outages. Regularly inspect and test the emergency power system to verify that it is functioning correctly. Keep accurate records of all inspections, tests, and maintenance activities. By following the NEC requirements and the manufacturer's recommendations, you can help to ensure that your emergency power system is ready to provide power when needed. The National Electrical Code, or NEC, is a comprehensive set of standards that covers various aspects of electrical installations. It is important to consult the latest edition of the NEC and any applicable local codes to ensure compliance. When working with electrical systems, it is crucial to prioritize safety. Always to energize circuits before working on them, and use appropriate personal protective equipment. If you are not qualified to work on electrical systems, consult with a licensed electrician. Emergency power systems are designed to provide power to essential loads during a power outage. These loads may include lighting, fire pumps, elevators, and other critical equipment. The automatic transfer switch, or ATS, is a device that automatically switches the power supply from the normal source to the emergency source when a power outage occurs. The ATS is a critical component of the emergency power system, and it must be properly installed and maintained to ensure its reliability. When selecting an ATS, consider the size and type of load that it will be supplying. The ATS must be rated to handle the full load current of the emergency system. Also, consider the transfer time of the ATS. The transfer time is the time it takes for the ATS to switch from the normal source to the emergency source. A shorter transfer time is generally desirable, as it minimizes the interruption of power to the essential loads. The location of the ATS is also important. The ATS should be located in a readily accessible location, and it should be protected from physical damage. The ATS should also be located in a well-ventilated area to prevent overheating. Regular maintenance is essential for ensuring the reliability of the ATS. The ATS should be inspected and tested regularly, and any necessary repairs should be made promptly. The maintenance schedule should be based on the manufacturer's recommendations and the specific operating conditions. In addition to the NEC requirements, there may be other applicable codes and standards that apply to emergency power systems. These codes and standards may include local building codes, fire codes, and accessibility requirements. It is important to consult with local authorities to determine the applicable requirements. Emergency power systems are an essential part of many buildings and facilities. By following the NEC requirements and other applicable codes and standards, you can help to ensure that your emergency power system is safe, reliable, and compliant. Always consult with qualified professionals for the design, installation, and maintenance of emergency power systems. In the context of NEC Article 701.17 regarding accessibility, readily accessible typically means that the equipment can be reached quickly and without obstruction. This might involve ensuring that there are no locked doors or other barriers preventing access to the ATS. Furthermore, the working space around the equipment must comply with NEC Article 110.26, which specifies minimum clearances for electrical equipment. These clearances vary depending on the voltage of the equipment and the presence of exposed live parts. It is essential to refer to this article to determine the specific clearance requirements for your installation. Regarding NEC Article 701.18 concerning the separation of power sources, the primary intent is to prevent a common mode failure from disabling both the normal and emergency power systems. This separation could involve locating the emergency generator in a separate building or a fire-rated room. The specific requirements for separation depend on the type of emergency power source and the building construction. For example, if the emergency power source is a generator, it might be required to be located in a separate room with a fire resistance rating of at least 2 IOs. If the emergency power source is a battery bank, it might be required to be located in a separate room or enclosure with adequate ventilation to prevent the accumulation of flammable gases. It is important to consult with local building codes and fire safety regulations for additional guidance on separation distances and other requirements. In addition to the physical separation of power sources, it is also important to consider the electrical separation. This means that the emergency power system should be electrically isolated from the normal power system to prevent a fault in one system from affecting the other. This can be achieved by using separate conduits, raceways, and grounding systems. It is also important to ensure that the emergency power system is properly grounded to minimize the risk of electric shock. The grounding system should comply with NEC Article 250, which specifies the requirements for grounding electrical systems. When designing and installing emergency power systems, it is important to consider the specific needs of the facility and the type of loads that will be served by the emergency system. For example, hospitals and other healthcare facilities have stringent requirements for emergency power systems to ensure the continuity of critical services. These requirements are typically specified in NFPA 99, standard for healthcare facilities. Other types of facilities, such as data centers and telecommunications facilities, also have specific requirements for emergency power systems to ensure the reliability of their operations. It is important to consult with qualified professionals to determine the appropriate emergency power system for your facility. Emergency power systems are a critical part of many buildings and facilities. By following the NEC requirements and other applicable codes and standards, you can help to ensure that your emergency power system is safe, reliable, and compliant. Always consult with qualified professionals for the design, installation, and maintenance of emergency power systems. Remember to consult the latest edition of the NEC and any applicable local codes to ensure compliance. The National Fire Protection Association, or NFPA, also publishes standards related to emergency power systems, such as NFPA 110, Standard for Emergency and Standby Power Systems. This standard provides detailed requirements for the performance, installation, and testing of emergency power systems. It is important to be familiar with these standards when designing and installing emergency power systems. In addition to the code requirements, there are also some best practices to follow when designing and installing emergency power systems. Firstly, conduct a thorough load analysis to determine the essential loads that need to be powered by the emergency system. This analysis should consider the power requirements of each load, as well as the duration for which the emergency power system needs to operate. Secondly, select an emergency power source that is appropriate for the size and type of load. Generators are typically used for larger loads, while battery systems are used for smaller loads or for applications where a short transfer time is required. Thirdly, design the emergency power system with redundancy in mind. This means providing backup components or systems to ensure that the emergency power system will continue to operate even if one component fails. Fourthly, install the emergency power system in a location that is protected from hazards such as fire, flood, and vandalism. The location should also be easily accessible for maintenance and testing. Fifthly, implement a comprehensive testing and maintenance program for the emergency power system. This program should include regular inspections, testing, and preventative maintenance to ensure that the emergency power system is ready to operate when needed. Sixthly, train personnel on the operation and maintenance of the emergency power system. This training should include instruction on how to start and stop the emergency power system, how to troubleshoot common problems, and how to perform routine maintenance tasks. Seventhly, keep accurate records of all inspections, testing, and maintenance activities. These records can be used to track the performance of the emergency power system and to identify any potential problems. By following these best practices, you can help to ensure that your emergency power system is safe, reliable, and compliant. Always consult with qualified professionals for the design, installation, and maintenance of emergency power systems. Remember that safety should always be the top priority when working with electrical systems. Always to energize circuits before working on them and use appropriate personal protective equipment. If you are not qualified to work on electrical systems, consult with a licensed electrician. Emergency power systems are a critical part of many buildings and facilities, providing essential power during outages. Understanding and adhering to the NEC and other applicable standards ensures safety and reliability.